Okay, a very good morning. To go further with your current work, I will show you what you can do quickly. Just go to SwissADME. Already, I'm busy on this site. So, when it comes up like this site has undergone a very great transformation lately. So go to browse the resources, and then you see all the available options, so many tools that you can work with. But our interest is in the pharmacokinetics of drugs, so we'll be using SwissADME, and that's already here. See, it's highlighted already. What we want to do here is just estimate or predict the pharmacokinetic properties of the drug. So once you have got in here, during your download, I asked you to save the SMILES formula for all the compounds you identified from literature. So here, I will use this example. We have aspirin, that's acetylsalicylate. It's already an approved drug. Then you see the SMILES here. You just copy, and then you come to the site here, you paste. I have another example, mupirocin, an antibiotic, and it's it's a big compound, a large compound. So you just copy all, and you also come here, enter, and paste. This one is very, very key. You must ensure that each compound is on a line. So for the first compound here, for the second one here, in your own case, based on the samples you're working with, you may have more than even 20, 30, whatever compounds you have on your list. Just ensure you enter them like this. If you already have them on an Excel sheet, just copy all, right click, go to Notepad, right click, paste as plain text. All the demarcations will go off, and then you have all the SMILES there appearing as individual compounds on a line each. So you just copy all of the compounds there, and then you come paste right here. Once you have done that, you click run. You give it some time, most times very quick, okay, as it is in this case, because you have just two compounds. So you can see, you go back and confirm, just do a random check to ensure that what you imputed is what you're getting. So you have the SMILES for the first compound here, and then the SMILES for the second one. You can see all of that. Now, like I said, our interest is in the pharmacokinetic parameters. In pharmacology, we talk about pharmacokinetics and pharmacodynamics. And in lay terms, we say pharmacokinetics encompass absorption, distribution, metabolism, and excretion. And more recently, some authors will add toxicity. So you see ADME. But this is fair enough, because our interest is to really identify what are the pharmacokinetic parameters of the drug or the compound of interest. So pharmacokinetics, like I was saying in lay terms, is what the body does to the drug, and then therapeutic action is defined by pharmacodynamics. That is what the drug does to the body. And for the drug to actually deliver its therapeutic potential, it must go through both phases. But this is the interest, because it's important to ensure the drug gets to the target site before you can expect pharmacodynamic action. So basic parameters you're looking at, you have physical-chemical parameters, see steroid definitions, you have lipophilicity and water solubility. Yeah, this is very important because the either lipophilic or hydrophilic, whatever state the compound is, may significantly affect absorption. They have other parameters like GI absorption, that's gastrointestinal tract. You have the blood-brain barrier, and if the particular compound of interest is substrate for all of these. Quite important because enzymes can sometimes digest these compounds and then they become unavailable. So it's also important to know. Then this part, drug likeness, is a very, very key area in drug design. So this Lipinski, if I put my mouse here, I can get more information about the drug. So a molecular weight, for example, must be equal to or less than 500. So if you check for this drug, it's 180.16. So there's no violation, zero violations. So you can just check all the other parameters, then go to the online. You can go online to get more information about each of them. But the most common is the Lipinski rule, and the compound that should be used as a drug should meet all of these parameters, basic parameters. So once you have done that, it's same for the other drug too. Just come here, click Save CSV, Retrieve as CSV. If you click this, it downloads all this information into what do you call it now? Comma separate, CSV, comma separated values here. So the file drops, and then you can open. Let's see how it's like. So you see all of them: formula, molecular weight, heavy atoms, so all plotted out based on the categorizations. What I do normally is, based on the categorizations, like water solubility, just name it, you can now group the parameters together, and since you have them there, you can plot or present as tables, whichever is convenient. So that's just about it. So once you have done this and you have this information, I will now show you how to go about the enzymes or protein targets of interest. All right, thank you.